Hi, okay. So what we're going to do then today is continue on with 1.6. So 1.6 is moving on more into complex numbers. So when something is a complex number, it means that it's going to have both a real and an imaginary portion. So this real portion is going to always go in front, and then the imaginary portion is going to be what's attached to this I. So we write a complex number in the form of an a plus bi, again, where a is real and where b is the imaginary. So an example of this would be if I had the expression 3 plus 5i. I don't know if you can tell it's an I or not. Okay, 3 plus 5i. Again, 3 would be my real portion of this complex number, and the 5i would be the imaginary. So in some points in times, we have to do operations between complex numbers. So we're going to show you how you do each of those here today. So when you add complex numbers, it's as simple basically as you think. Let's practice 8 plus I added to C. No, so that's not what I wanted. I wrote the wrong thing. Plus 5 plus 4i. Okay, so essentially when we add complex numbers, it's the exact same thing as combining like terms. So we just have to combine the things that look alike each other. So 8 and 5 can be added together because they're both the real portions of those complex numbers. And I can be added to 4i because those are both the imaginary parts. It's kind of like if we throw an x on here, you'd be able to combine things that had a variable and not that didn't. So you'd only combine constants or only combine things with variables. So when you add these up together, this is going to be 8 plus 5, which gives us 13. And then we add I plus 4i. We add these just like we would if there was an x. So if we have 4i and then we have 1i, that leaves us having 5i. Okay, so in the end here, it's going to be 13 plus 5i. So again, adding is really straightforward. There's nothing complicated to it except the fact that we put an I in there now instead of maybe a variable that you were used to. So then with subtraction, let's do 3 plus 7i minus 8 minus 2i. So the one thing you have to remember is that with complex numbers, they're written in these binomials. So any operation happening outside of that binomial needs to be distributed to everything within that binomial. When we have subtraction, it's kind of like the same thing as distributing a -1 throughout that binomial. So I need to do that step first. So this is going to be the same thing as writing 3 plus 7i. And then we're going to distribute this negative, and I'm going to actually erase these parentheses. We're going to distribute this negative to both the 8, positive 8 times a -1 is -8. Negative times negative makes this positive, so we're actually adding 2i on that. Okay, so that first step is always going to be distribution. Now I'm going to go ahead and combine like terms, 7i and 2i, and then 3 and -8. 3 plus -8 is -5. 7i plus 2i is positive 9i. And that would be my new complex number after subtracting those two together. So when we're dealing with either addition or subtraction, they're pretty straightforward. It's exactly the same that you would deal with these if it was just any other variable. When we come with more like maybe multiplication or even a little bit of division, that's when things get to be a little bit more tricky. So with multiplication, let's do two binomials. So this is going to be 9 minus 2i multiplied by the quantity of -4 plus 7i. Okay, so when we multiply two binomials together, you can think of this in any way that you want. I know you've maybe been taught to FOIL in the past, which would be first outside, inside, last. That's how you do it. That's more than okay. Whatever you do to be able to multiply these two together. I'm going to start by taking 9 times -4, right? That's going to give me -36. Then I take 9 times 7i. So if this were a variable, we would say that we want to keep that variable, right? I can multiply these two things together, but that variable has to stay on there. So this is going to be 9 times 7i. It's going to be positive 63i. Okay, just like if there were an x there. Now I'm done here, so I'm going to move on to my next one. Now I have -2i times -4. It's going to become positive because of the two negatives. 2 times 4 is 8, and that I still gets attached. So my very last one, -2i times positive 7i, it's going to be -14. And since we had two i's being multiplied together, that's going to be I squared. So we talked before in the fact that I squared equals -1, right? So I always said when you are working with any kind of function that has an I squared in it, you're going to want to simplify that. You're going to want to put in that value of -1 for the I squared. So we're going to do that here. Doing this, we have -36 plus 63i plus 8i minus 14 times -1, right? Just putting in a -1 instead for that I squared. Okay, so we continue going through. I still have -36, and then I can combine these two like terms, right? We have a positive 63i and a positive 8i. I can combine those two like terms to get positive 71i. Okay, I can combine like terms in here as well. -14 times -1 is going to give me a positive 14. So the last thing I have left to do is combine these two constants of like terms, which I like to keep my constants here out front when I'm dealing with complex numbers. So it's going to be -22 plus 71i. Okay, and this would be my final answer. Some students will ask, well, could I have left it at this step or this step or this step? The answer is no, because we never leave anything until it's completely simplified. That is when all like terms are combined. All right, so that is multiplication. There is never any weird scenarios that will happen except for getting that I squared. So seeing that one example is pretty straightforward for the rest of the examples that you might see. So the last example then is going to be a little bit longer of one. This is when we are dividing complex numbers. So we're going to divide 7 plus 5i over 1 minus 4i. So when we're working with division, you can set that up as a fraction. The important thing to remember is that if I have addition happening in my numerator or addition happening in my denominator, I can't go through this cancellation process. Some people would like to say, well, let me cancel these i's out or do something like that. You cannot do that because of the fact that this is not only 5i over 1 minus 4i, it's also 7 over 1 minus 4i. So I cannot cancel out anything in this denominator because of the fact that I have more in my numerator that's also being set over that denominator. So instead what we do is a process called multiplying by the conjugate. So if you did any of the honors topics, you'd be a little bit familiar with doing this. Basically, what a conjugate is we take this denominator with an opposite sign. So this is a 1 minus 4i. I'm going to change it to 1 plus a 4i. And I not only write that in my denominator, but I write that in my numerator as well. So some people ask, why is this legal? How can I do this? If you take 1 plus 4i over 1 plus 4i, that's just equal to 1. Okay? So when I'm multiplying by a conjugate, it's essentially multiplying by a value of 1. So I'm not changing the value of my function at all. I'm not changing the value of this division of complex numbers. I'm only altering it. I'm altering the form that it looks like to be able to simplify and do this division. I'm not changing anything about the value though. So now we go back to what we did before. Okay, now we're back to kind of multiplying complex numbers together, because when I multiply a fraction by a fraction, I multiply straight across. So I'm multiplying the numerators together and I'm multiplying the denominators together. Okay, so what we're doing is essentially everything in the last step kind of times 2. So I have to do it in both my numerator and then also in my denominator. So this might be a good point to kind of like pause this video, try to do this multiplication on your own, and then check back with me to see if you did it okay. Okay, so we binomial these up, 7 times 1, and I'm also going to have 7 times 4i. Okay, so 7. Okay, so if you're coming back, you should have 7 plus 28i plus 5i plus 20i squared. Okay, then we're going to go down to our denominator and do the exact same thing. 1 times 1 is 1. 1 times 4i is 4i. Then we have negative 4i. And then we have 16i squared. Okay, so before I keep going at all, I'm going to start with my I squareds. Again, I squared is just equal to negative 1. So what I'm going to do is replace both of these, and I'm actually going to come in here because I don't have that much room, and literally replace it. So here's a negative 1, and here's a negative 1, and now I'm going to deal with that. Right, so I'm going to rewrite this entire function while combining my two like terms. Okay, so positive 4i and negative 4i cancel out. Those go down to actually 0. I'm going to combine my 28i with my 5i when I rewrite this. Okay, so I have 7 plus 28i plus 5i is going to give me 33i. And now I have 20 times negative 1. It's going to give me negative 20. And 1, I already said that positive 4i and negative 4i cancel out. Now I have positive 16 times negative 1, which gives me negative 16. Okay, the very last step I have to do here is just combining these last two constants together. Oops, that's an equals. Okay, so 7 plus negative 20, that gives me negative 13, still added on to this 33i. And in my denominator, I have 1 minus 16, it gives me negative 15. Okay, at this point, if I could cancel anything, I could kind of split up this numerator over denominator and numerator over denominator to try to cancel anything out if I wanted to. But this is the point that I'm finally simplified down. The point of this was that I was able to kind of do this division and, wait, 1 second. Oh, there should have been a negative 16 over here. Sorry about that. when we multiplied -4 times +4, it should have been -16. It's going to be a +16 down here. So, yes, over 17. Good. Okay, that's better now. Okay, so I just messed up when I did negative times positive. I said it was +16. Should have been a -16 right there. To give us 1 plus 16 is +17. Okay, so sometimes the very last step I like to do is split this up. And I like to say, okay, this over that and this over that. So splitting up these fractions as -13 over 17 plus 33i over 17. What this allows me to do is simplify down this fraction if possible, and simplify down this fraction if possible. I can't in this scenario, so this will be my final answer for this division. Again, what multiplying by the conjugate does is I'm left with no imaginary numbers here in my denominator. We don't like to have them in the denominator when this happens. Up here, whenever I have multiplying by a conjugate, it's essentially multiplying my I by my I to get this I squared. To get rid of it to -1, your two normal i's in the middle should always be opposites of each other, so they should always cancel out, always leaving me without an I in my denominator. If you ever got one, I would kind of backtrack and see maybe where a mistake was made or something like that. Okay, so that is as far as we need to go into this.